Hey guys, today we're going to look at piecewise functions and then learn how to graph them. So piecewise function is a function that has at least two different functions or pieces. So we're going to start with an example. Information is going to be given to us in a table. So we have a park or a museum or something that we have to pay admission to. And here's a table for the admission price. So if you're under 12, you only have to pay $5. If you're between 12 and 50, you have to pay $12 of admission. And then if you're over 50, it's $10. So I'm going to go ahead and graph this function. So I created the graph. I didn't label my axes, which is my fault, but the x-axis is your age. The y-axis is the price. So if you're less than 12, that's about right here. That means we pay $5. So obviously we cannot be a negative age, which is why this does not go negative x values. But anywhere between 0 and 12, our price is $5. So I make a line segment from 0 to 12 on my x-axis, and my y-axis is at 5. That first piece right here takes care of the top row. Then if we're between 12 and 50, we're going to pay $12. So if I am 12 years old, I will pay $12. So I go to that 12 on my x-axis and fill in that dot because at 12 years old, I will have to pay $12. Okay, again, this height is at $12 on my y-axis. So age 12 all the way to age 50, I'm paying $12, which is what that y value tells me. And then if I'm over 50, I'm going to pay $10. So at 50, I come up to the 10 on the y-axis, and this circle will be open because if I am 50 years old, I can still pay that $12. I have to pay, or I have to be completely over 50 in order to get the discount. So at age 50, I will pay $10 if I'm over that. So open circle with an arrow pointing to the right, meaning anything to the right of 50 years old will only have to pay that $10. Here is actually a definition first. So what we just saw is what we call step function. Step function means it looks like little steps. Each piece is constant over an interval on the domain or the x values. So that was an example of a step function. Here is another step function. So we have constants. Constants, remember, are just a number. So we have different numbers that are defined in a function. Our goal is to evaluate when x is 0 and when x is 5 based off of this defined function. So here is what a piecewise actually looks like when it's defined. We use function notation, so f of x equals, and then we have a curly bracket. Our curly bracket's only on the left side. We never put it on the right side. It will always have some sort of function, at least 2, remember, so you might only have 2. This one has 3 pieces. So this portion right here, what are constants in this example, these are our y values, and then our stipulations are over here on the right, and this is our domain restriction. So when x equals 0, we have to decide what is the y value of this domain value or this input value. So I said earlier, our domain or our inputs are right here in this second little portion of our function. So I'm looking, when is x equal to 0? Well, there's a 0 and there's a 0. So I know it has to be between the top 2 functions. And then this is x equals. So we have to decide out of these 2, where is x equal to 0? Well, here we have strictly x is less than 0, and here we have 0 is less than or equal to x. So we have to use this middle piece of our function. So when f is 0, let's see if I can, when f is 0, we have our y value is negative 5 based off this middle piece. Okay, when x equals 5, again, these are my y values. So one of my answer for x equals 5 will be one of these three constants. But in order to decide which of these three constants, I have to use my domain restriction. So when is x equal to 5? Well, top value is not, the top piece is not in the picture because it's strictly less than 0, and 5 is obviously greater. So now it's between our middle and our last piece. Again, x has to be equal. This says x is less than 5. This says x is greater than or equal to 5. So we are going to use this bottom piece of our function to find f of 5. And f of 5 then is this y value, or this output value of 2. I'd like you guys to find f of negative 3. Okay, next we are going to write an equation based off of a piecewise function. So here's another graph. This is a step function because it's constant over this interval. So we needed to write an equation similar to what we just saw in our last example. So we always go left to right. We have a y value of 2 when our x is equal to 0 all the way up till positive 2 on the x-axis. So that's going to look like this. Our output, or our y value, is 2 if my x value is between 0 and 2. Since this circle is closed, that's why we have the less than or equal to. But at x equals 2, our circle is open, so it's strictly less than 2. Now we go up to our middle piece. The y value is 4 from 2 to 4 on the x. So an output of 4 for my x values 2 to 4. Again, closed circle on 2 means less than or equal to. Open circle on 4 means less than. And finally, this third piece has a height of 6, or a y value of 6, when x is between 4 and 6. Okay, so 4 and 6. So this is our piecewise function based off of this graph. And finally, you'll be asked to graph something like this. So here's a piecewise function with 3 different pieces. This time they actually have variables, so it's not going to be a step function. These are going to change. So in order to graph this, we're going to have 3 different tables. So I already created our tables based off of these 3 domain ranges. So I should say domain intervals. So this first piece, 2x plus 1, I went ahead and chose x values that were less than negative 1. So negative 3, negative 2, and negative 1 are the x values that I chose. I went ahead and plugged negative 3 into this function. So 2 times negative 3 is negative 6 plus 1 gives me negative 5. And then negative 2 times 2 is negative 4 plus 1 is negative 3. Likewise with negative 1. I did the same thing for these middle and bottom pieces. So for negative 3x, I chose my x values to be negative 1 through positive 2. So negative 1, 0, 1, and 2. Plugged those x values into the middle function. And then for our bottom piece, I chose x values larger than 2. So 2, 3, and 4. Plug 2, 3, and 4 back in here to get my y values. Now I have points to actually plot. So starting with this piece, I plotted negative 3, negative 5, negative 2, negative 3, and then I put an open circle on negative 1 because it was strictly less than, meaning it cannot equal negative 1, so it's an open circle. Then I plotted my middle piece, which goes from negative 1 to positive 2. This circle on positive 2 would be open for this middle function, except if you notice, the bottom value in this XY table and the top value in this XY table are the exact same. So that's why it got filled in, because of this second piece. And then I plotted these 3 points to give me that third function. And that's how you graph a piecewise function.